Welcome back, Stella. Hope you are doing good. Before going to these two exercises we have to do, I would like to mention something about this last exercise we did. Let's go back to it. At this stage, at this stage, at this stage. Okay, because there are there is an approach. I told you there are two ways of going about to integrate this. So there is an approach that you will see in some textbooks. There's an approach that you will see in some textbooks. It's the same approach, but just that this my approach is a bit more faster. You understand? So let me explain the approach. So we are to integrate. Let's allow this 15. My problem. Let's concentrate on this. So our aim is let me take a page, a rough work. Our aim is to integrate 1 all over 9 plus 4 into x plus 1 squared dx. In some textbooks, what they are going to do is that they will do, in fact, they will proceed in doing this integral by using two substitutions. The first substitution is they will first try to make this resemble this 1 all over a plus b x squared. That will be the first substitution they will do. So that is, there should be, I should not have x plus 1 here. Let me stay inside 1 all over a plus bu squared, because so they will do, the first substitution will consist of making this thing resemble this. So here, don't be afraid, the result will be the same. I'm just trying to go to explain this approach because you can see that in some textbooks, and don't think that it's a wrong approach. It's still a correct approach, just that my approach is faster than this approach. You understand? So I will let u to be equals to what? X plus 1. If my u is equals to x plus 1, what will be my dx? I differentiate this implicitly. When I differentiate this u, I have 1 times, then I multiply by what? Du. This will be equals to, I differentiate this gives 1 times, and I multiply by dx, it gives dx. This one will give 0 times dx. Now, we see that du is equals to what? Dx. I'll substitute things inside here. So this implies the integral of 1 all over 9 plus 4 into x plus 1 squared dx will be equals to what? The integral of 1 all over what? 9 plus 4 u squared. What was dx? Dx is simply du. So you notice that, what do you notice? You notice that you are already in the form what? It's like you are integrating a plus bx squared. You understand? So now, what are we supposed to do? What we are supposed to do is to rearrange this such that it should be in the form 1 plus something or that square dx. You understand? So what I will do is that I factorize 9. This becomes okay, let's leave our 15 here because I want the result to be exactly as what we had. So I will have 15 outside here. So this will become 15 on the 9 integral of what? Du all over. I factorized 9 here. So what remains here is 1 plus. This will be 4 on 9 u squared. I hope that's okay. Now, the next step will be to bring what? This inside. So this 3 here, 3 times, 3 here, 5 times. This will be the integral of what? Du all over what? 1 plus the square root of 4 on 9 all squared times x squared. You understand? This is du up here. This will be equals to what? This will be equals to 5 all over 3. 5, wait a minute. I want to have some more space. Let me move this right here. Okay. Oh, I need to move this integral sign. This is it here. Okay. Now, this will be equals to what? This will be equals to the integral. This will go inside. And we know that square root of 4 on 9 will be 2 on 3. So this will be du on what? 1 plus 2 on 3u squared. This is a, this is u, not u squared. It's not x squared, u squared. Now, we are already in this form where we have 1 plus what? Something other square. The next substitution, what's the, when we have already this, what's the substitution we are supposed to use? The substitution is tan. So the next substitution we shall do is let tan theta be equals to what? 2 on 3u. What will be du? I differentiate this implicitly. This will give me the derivative of tan theta is simply 1 plus tan square theta or sec square theta. I write here d of theta since I was differentiating with respect to theta. When I differentiate this with respect to u, this gives 2 on 3 times du. Okay, 2 on 3 times du. Now I'll substitute things. I'll start substituting things. So this is where we ended. This 5 on 3 integral of du on the 1 plus 2 on 3 u all that square will be equals to what? 5 on 3 integral of what? My du here, if I'm to make du the subject, my du will be equals to 3 on 2 into 1 plus tan square theta times d theta. Are you okay with me? Try to verify that that's the answer. So this will be equals to, I replace my du, which is 3 on 2 into 1 plus tan square theta d theta all over what? All over 1 plus this 2 on this 2/3 u was equals to what? Tan theta. So since there is a square here, I will have tan square theta. You see that this goes with this. Now we'll be left with, let's look at it. We'll be left with 5 on 3 integral. Wait, we'll be left with 5 on 3 times what? This 3 on 2. 3 on 2 integral of what? What remains is d theta, d of theta. So this will be equals to 5 on 2 integral of d theta is theta plus our constant of integration. Now, what was our theta? Recall that tan theta was equals to what? 2 on 3u. This implies theta must be equal to what? Arctan of what? 2 on 3u. But recall also that what was our u? Our u was equals to x plus 1. Recall also that our u was equals to what? X plus 1. So where I see u, I replace by what? X plus 1. So it implies theta will be equals to what? Arctan of what? 2 on 3 into x plus 1. So we basically see that this implies 15 integral. This was the exercise here. 15 into the integral of this, into the integral of 1 all over 9 plus 4 into x plus 1 squared dx will be equals to what? We see this theta, I replace this theta by this. This will be 5 on 2 arc tan, or the tan inverse, or the tan inverse, arc tan, or the tan inverse of what? 2 on 3 into x plus 1 plus our constant of integration k belonging to r. So you basically see that we have the same results. The only difference between these two methods is that here we basically use two substitutions. This is the first substitution we use, and the second substitution was what? The second substitution was this. This is the second substitution. You understand? So try to learn these two approaches. It's very important for you to know them. You understand? And whenever you have so many methods, learn all the methods and choose the methods you think it's very easy. It's fast. It will take you less time and it's very simple. Master all the methods, but in an exam, use the method that will take you less time. You understand? So you are the one to judge and decide on which method takes you less time than the other. Master all the methods, but in an exam, apply the method that will take you less time, because in an exam there is you are how will I say, there is time. In an exam you don't have the whole day. There is time. You are working on time. So master all the methods, but in an exam, use the method that will be that you think will be very fast for you. That will take you less time. Okay. So see you in the next videos. The next videos for us to do these two exercises. So that was just an important point I wanted to mention about this last integral we did. So see you in the next video.